Thanks, Darlene. This afternoon, I'm just going to talk a little bit. We're going to give a couple short case studies that sort of demonstrate the broader impact that the whole machine-to-machine and Internet of Things technology is going to have on our industry and actually a lot of other industries. I reference a report that was done by the Carbon War Room that talks about the machine-to-machine industry and the fact that they're predicting it'll grow by 20% per year for the next 10 years and will be $1 trillion industry by the year 2020. The whole idea of machine-to-machine and Internet of Things is creating a whole new series of managed services businesses that are having a dramatic impact on business processes and really revolutionizing, in some cases, how work gets done. And they specifically talk about 4 industries that are going to be most impacted by the whole trend of machine-to-machine. So one is the energy services industry, and there they're talking about the production and transmission of energy. And so the example there would be the smart grid. Clearly, new technology is going to have a big impact on that industry. A second industry is the agricultural industry, one that you don't think of often as being very high-tech, but an example they give there is companies like John Deere that have technology now that will deliver the exact right amount of fertilizer and herbicides and pesticides in each square footage of soil in their fields based on prior testing and mapping of the soil. And all that being done by tractors that are driving themselves because of GPS technology. So machine-to-machine and technology is going to have a big impact on that industry. The third industry that they mentioned is the built environment, one that we're all here to talk about today. And it's really going to change the way that we manage and operate buildings. It's going to change the way that we manage and operate our homes. Darlene gave the example this morning of the Nest thermostats. It's an internet addressable thermostat. Doesn't seem like a big revolutionary concept, but there's a reason why Google paid $3.2 billion to buy a thermostat company, because they see a future in this interconnected world. So I'm going to give a little case study in a minute about how we're deploying some of this technology for the built environment for one of our clients. And then the fourth industry is the transportation industry, where it's going to change everything. Where, a lot of talk about autonomous cars. Our partner Pacific Controls has worked with a leading manufacturer of golf carts. It's putting this technology so they can track the conditions of the motors and the batteries and where they are and how often they're being utilized. Or things like airports, and he'll give an example of work that they've done at the airport in Dubai. So the case study I'm going to give relates to Procter and Gamble. I think everybody has at least heard of Procter and Gamble, or at least knows about their products, but what you may not know is that they are a very data-driven company. They really run their business based on as much real-time data as they can get, and I had the pleasure of sitting in their boardroom and having them give me a demonstration of how that works. And they can, it's very sort of CNN election day coverage kind of thing, where they can touch screens and pull in and zoom in and tell you how many Pampers were sold in Warsaw yesterday, and then using that to inform their marketing and manufacturing business processes. So it's pretty incredible. So they're a very data-driven company. They're also a company that's very concerned about the environment. So they have goals to improve their own environmental performance, and they have goals to produce products that help their customers also treat the environment better. So one example of that are their soap products that are designed for cold water washing. And it's interesting. They have a goal to have 70% of the machine loads washed in cold water. And I don't know exactly how they're measuring all this, but again, they're a very data-driven company. And so by their calculations, if every U.S. household used cold water for laundry, the energy savings would be 33 million megawatt hours per year. Not surprising, at least not surprising to me. Europe is out a little bit ahead of us on this concept. So in the UK, largely through a lot of the efforts of P&G, 23% now wash in cold water. That's up from 2%, and in the Netherlands it's 52%, up from 7%. So they're also very concerned about the environment. So their interest in smart buildings was consistent with how they run their business. It was consistent with their data-driven culture. and it was consistent with their desire to improve their environmental performance. Their interest in smart buildings is also an extension of the technology model that we've deployed jointly with them. We're their real estate provider for transactions management and project management and facility management. And in delivering those services, we have technology that's integrated with their technology that helps track space and occupancy and usage and financial performance of facilities and lease expirations. But the one thing that was missing is how are the buildings actually performing, and how are they performing right now? How much energy are they using, and what can we do to improve that performance? So again, that fed their interest in looking at some real-time smart building type technology. Just a little bit more background, the kind of technology that we're talking about is made possible today because there have been some pretty incredible advancements in our industry. And I often, I can't help but mention that when I first got out of engineering school way back in the 1980s as a young mechanical engineer, I was very excited to read in the ASHRAE Journal about the whole advancement of the smart intelligent building concept, because they were developing this new BACnet protocol. And as a young engineer, that was pretty exciting. And here we are 30 years later, and we're just really now sort of deploying on that concept. The idea was developing communication protocols that enabled all these building automation systems and control systems to communicate to one another. And manufacturers had, and still in many cases have, proprietary protocols that hindered that communication capability. So the new development in the industry is that new companies have come in, companies like Tritium, companies like Pacific Controls, that are overcoming that obstacle and able to get in and get the data out of these systems. So that's one big change. And the other big change is now we have to do something with that data, something meaningful with the data. A lot of people talking today about we have too much data, and the key is to turn that into actionable information. So the creation of new software programs and algorithms that can extract the data out of the system and turn it into meaningful, actionable information. So smart buildings are getting smarter, they're getting more affordable, and there's a lot of companies that are entering in this space, and a lot of different models that you're starting to see deployed in the industry. The benefits of smart building can be long. The business case is often based on energy savings. In our experience, we've done this now in about, I think, 120 buildings, a little over 25 million square feet around the globe, and we're consistently seeing paybacks in less than 18 months, often less than a year. And in installations where they were LEED Platinum building. So the clear business case is on energy savings, but there are other benefits, and some of them are operational. And there was some discussion up here this morning about the building operating engineers and not forgetting about the building operating engineers, and that's one thing that we've very carefully factored into how we're deploying this technology, and that is that at some point, despite all these levels of automation, often somebody with a wrench or a screwdriver has to go adjust something or tweak something or fix something or repair something or look at something. And so we recognize that that's part of the equation, and I'll talk a little bit later about how we kind of incorporate them as a key part of the end-to-end process. So when I'm not doing my energy and sustainability role, I also oversee our engineering services operation. We have 5,000 building operating engineers out there that are afraid that I'm trying to put in technology to replace them, right? And so the analogy I often use is it's a new tool. And it's like giving a doctor an MRI machine. It enables them to see deeper into the building and see how all the systems and equipment in that building are performing, and to see that in real time. And I often say that unless they have enough staff to watch every valve and damper in the building operate, they can't do what one of these systems can do. So, and again, I'll give a few examples of that later on. So this is the model that we deployed for P&G and other clients. And it begins with using that technology to extract data out of the buildings. So we're pulling data out of existing building automation systems. We're running it through cloud-based algorithms and turning that into actionable information. Our model happens to run through a command center, which provides sort of additional layer of support. It's staffed with degreed mechanical and electrical engineers that can be work with the property teams when they need some of that deeper understanding on how to program control loops and things like that. And then we close the loop and feed back to the property. So we're taking all that information and turning it into action, either through commands directly back into the building or through a work ticket to an engineer. And it can't get more actionable than a work ticket to an engineer that says, go recalibrate this static pressure sensor, right? So we think that's a key aspect of deploying this kind of technology because there's accountability. We can see if they did it, and we can see after they did it have the impact that we thought it would. So it all begins with, I'll run through these slides quickly, getting the data out of the building, as I said, so new smart devices that are out there that enable you to get the data, and then to analyze that data and make sense of it, to optimize energy, to optimize the performance of the building systems and equipment all the time in real time. So you hear concepts like automated continuous commissioning, and it's that kind of thing. It's acknowledging that buildings get out of calibration very quickly. A lot of studies about brand new buildings, LEED Platinum buildings, and how performance degrades over time because sensors get out of calibration, things get adjusted, things get overridden, and there's a whole industry of retro commissioning where people come back in and bring the building back to the original design intent. With technology, we can do that on a continuous basis. The staff command center I mentioned, again, just sort of adds that extra dimension, recognizes that we can't do all of this with just technology, and sometimes you need some subject matter expertise and create that linkage and working with the property team. There are a number of deliverables that can come out of these systems. A lot of property owners are struggling with doing reporting, Energy Star reporting into GRESB or Greenprint or some of the other reporting. This is a great way to get data, to automatically, in some cases, populate that data. So there's all sorts of output that you get out of it. But the key really is turning that data into actionable information. So I hear a lot of people in the industry talk about smart building technology, and they're pulling out 77,000 data points a day. And to me, that's just meaningless because that's not the point. The point is getting the right information out of the building and then doing something meaningful with it. And the measure of success shouldn't be the number of data points. The measure of success is how many kilowatt hours we've reduced energy in the building, or the measure of success is how we've been able to reduce reactive work tickets because we identified a piece of equipment where the performance was beginning to degrade and made a repair before a failure occurred, and enabled the operating team to get out ahead of those kinds of things, find things and fix them before they break. So I think that's, if there's one lesson, that's a key one, is really turning the data into real actionable information to improve the performance of the buildings. And I'll give a few examples on the things that we found and things that we did with the Procter and Gamble installation. So Procter and Gamble was one of our first big clients for this IntelliCommand service, and overall very successful. We deployed in 12 buildings, 4 different sites. They picked a variety of building types to kind of test it out. So there were labs, there were a warehouse type space, there was their headquarters office building. And we saw, savings ranging anywhere from 8 to 16%, kind of average 10% overall in the first 11 months. But the kinds of things that you find are things like dampers or valves that aren't working right. So when the valve is commanded closed, it doesn't really quite close all the way, and water is leaking through. And we can detect that because there's obviously a temperature differential that you're identifying. Dampers that aren't working right, static pressure sensors that aren't measuring correctly, and now the fan is working harder than it needs to. And these building systems and equipment are very resilient. Many times it'll sort of make up for things that are out of calibration and still deliver the right amount of air to the space and everyone's comfortable, but the system's working harder than it should be. This kind of technology can help you identify those situations. One of my favorites is, and we found this a lot in the single-story type buildings for P&G, with rooftop air conditioning units in a climate northern climates where they could be operating in an economizer mode during certain times of the year. So this is where you're bringing in outside air for free cooling, right? The idea is it's free cooling. You're running the fans, but not the compressor when it's below 55 degrees outside. Well, those are notorious to fail. And the damper doesn't work right, the actuator doesn't work right, a sensor doesn't work right, and you're not bringing in the cool outside air. So what the system does is starts the compressor. So everybody inside the space is happy because it's still delivering the right amount of cool air, except you're running a compressor when you don't need to. The maintenance cycle on those units is often quarterly, so no one's getting up on the rooftop to look at those things, and so that condition can be it can be operating in that condition for a long time. With technology like this, you know at the instant it happens, and you can again issue a work ticket to an engineer to go look at rooftop unit number 3 and find out why it's not operating in economizer mode. So those are real examples that we found on Procter and Gamble that in aggregate led to these kind of savings. So like I said, we started with 12 buildings. They're very happy with the result. They've now asked us to extend to 76 buildings around the globe, and so we're in the middle of that right now. So that's the Procter and Gamble story, and kind of a real life example of how this technology is being deployed and actually working today. I still hear a lot of times at some of these events where they're talking about the future of smart intelligent buildings, and I would say that the future is here. We're able to do a lot of this stuff today. So that's one example. I'm going to invite my partner Sajad Chaudhry from Pacific Controls to come up. They're our partner with IntelliCommand and talk about a different type of installation. I'll say when we first wanted to deploy technology like this, we looked all over the world for a partner that could help us do it, and we did a very formal RFP process and took proposals from all of the big companies that you've all heard of in this space. But only found one that really was doing what we wanted to do and very forward-looking in terms of this whole idea of machine-to-machine and Internet of Things, and that was Pacific Controls. So I'll let Sajad come up and talk a little bit about what they did at the Dubai airport. That's pretty amazing. Sajad?
Thanks, Dan. I'll, hope everybody's enjoying their lunch. Thanks to core advisors and Arlene for providing the opportunity to sponsor the lunch. So hopefully it was good for everybody. I'll just take a few minutes to very briefly mention, Pacific Controls, who we are, and then talk about the kinds of projects that we've done that Dan has spoken about, and also another interesting one, which is the Dubai airport. So Pacific Controls is a global market leader in energy, building monitoring, life safety, and security systems, with over 50,000 buildings connected in Dubai and the rest of the world. Okay, the way we've been able to do this is we've created a platform called Galaxy, which this IntelliCommand services that Dan has talked about. The underlying technology is this platform called Galaxy that has been developed by Pacific Controls. And this platform is an end-to-end platform for managed services that proactively monitors assets, providing transparency into assets, whether they be buildings or machines. And it also provides transparency into where some of the faults might be, critical faults, and where the opportunities exist to significantly reduce operational expenses. Okay? The underlying theme for developing this was to significantly reduce the percentage of complexities involved in application development, management, and delivery of these kinds of systems. And it addresses the challenges of networking smart devices, developing M2M applications, and integrating complex IT systems. Okay? So in order to deliver a project like the Dubai airport that I'm going to briefly talk about, Pacific Controls is, forms a collaboration team, and we end up working with a broad spectrum of network operators, IT equipment players, professional service providers, software players, and equipment OEMs to deliver real-time management solutions for real-world systems. Okay, so we'll talk about this Dubai airport, specifically Terminal 3, which is I don't know if you get the opportunity to visit Dubai. This is a pretty exciting airport terminal. It's one of the ones that is designed specifically to handle the A380, which is one of the largest airplanes that flies in there regularly, and you see a whole bunch of those lined up outside the terminal when you go visit there. So what happens is, in this case, when an aircraft is close to the airport, I think it's about 60 miles out, it sends a signal to the airport, and then the systems that we've integrated and tied together takes over. So things that are notified even before the plane has touched down as to which gate the plane's going to be arriving at, and turns on the air conditioning for that jet bridge and mobilizes the people to the right location. This terminal, the way it's set up is when you land, you end up having to take some elevators, go down to the lower levels where you go through customs and immigration and things like that. So the system automatically kind of pulls these elevators up to the right level, so when people are deplaning, and if you can imagine, this was designed to handle A380 planes with a lot of people coming off, and if multiple planes are coming in, you can see the kind of the log jam that might happen right at the immigration and customs queues. So in order to move those people efficiently through, the right elevators and escalators start to be in position correctly. They take the people to the right place and move out. Obviously, all the air conditioning systems, lighting systems, even the digital signage that shows people where to go and which flight has arrived and so forth is tied into this. And most importantly, for the airport, the airport is able to generate an invoice for that airline that just landed and service the plane within a matter of minutes rather than the days and weeks it used to take before. So they're able to invoice the airline that just landed and took part in this, and then have a report sent out. Some of the things that you see around there, and we'll look at all the systems that are tied in. It goes through the gamut of security, mechanical, aviation systems, electrical, communications, etc. So even the fuel trucks are notified, where they're supposed to be, how much fuel is required. All that is moved into the right place, and you're able to handle the airport in a much efficient way. So this was done a few years ago, and based on the success we had there, as you know, Dubai is used to building the biggest and the largest and whatever the newest thing. They have also built now a new airport that is under, well, it's already operational, but just one runway is open yet. It's called Dubai World Central, and that is slated to be the world's largest airport. Okay, the project area is about 50 square miles approximately, and to give you some sense of what that is, I think Washington D.C. is about 68 square miles, so almost the size of Washington D.C. So it's got airports. It's supposed to have 5 runways that are supposed to be able to handle some of the largest planes that come through, and be able to handle about 160 million passengers a year. This Terminal 3 handles about 75 million passengers right now per year, but the Dubai World Central is going to be able to double that, more than double that. So Pacific Controls has got already involved in the systems to not only the airport stuff, but all the peripheral support infrastructure. So there's hotels, there's even a golf course at this location, and other systems, including managing the sewage pumps and irrigating the lawns, street lighting, you name it. All that has been tied in with a one complete system that is managed by the Galaxy platform. Okay, so that's you know, just another example. There's many others that we've done. We can talk about that, but I won't you know, bore you with those at the moment. This was meant to be just a quick introduction. So enjoy your lunch. Again, thanks, Darlene, for the opportunity.